We've been talking the past couple of days about how I can use inverses to solve things. We're going to stick with some of that today, but we're also going to take a step back further to help us on some stuff that was troublesome on our last quiz, because dealing with that stuff's important. So we're going to kind of bounce around again here today, checking out some of this stuff before you get the actual preview for the test tomorrow. All right, solve each equation. That seems familiar from yesterday. Round your answers to the nearest 10,000, or fraction, like we said before. So if you think back to yesterday for a moment, we talked about, okay, first I notice I don't see any logs here at the start, so I'm going to be using log as my inverse. Because again, log of a base and that number are inverses. That's not 11 times x. I wish I could just divide that and make this so much easier, but I can't. So instead, I'm going to use the log of that base to get rid of that 11 on the left side. And we're still having a little bit of a dilemma with some of you with what's going on here on the right. We're still dealing with change of base. We're still dealing with something I need to plug into the calculator that doesn't look like what I see on the screen when I go to plug it in. I can't plug it in one big thing and call it like log 11 6 or log 11 times 6 or any of that business. Instead, reminder again here, that when we do change of base, we do log of big, that 6 is physically bigger, okay, not that the number is, divided by log little. Every time we get into this situation, that's what it's going to look like. And so, as I start working towards my 10,000th here, which again is 4 decimal places, I get to the third. The fourth is 2, but I got to look at the number after it to see if it's going to be 2 or 3. If it's less than 5, and it is, it stays 2. But that's the type of stuff, once you get some practice, that becomes easy peasy. You just kind of whip through it. But if you haven't been practicing, it's a little bit trickier. Now, another thing, I saw some people who were coming and asking questions yesterday, good thing, is they'd look at this and they go, ooh, I'm just going to log 20 everything right now. Not quite. That's got to be alone before I can do that. So I look in front of it. Okay, what am I doing to it? I'm multiplying it times negative 6. I've got to do an opposite. So, now again here, I can leave that as a fraction. I can go ahead and try to do it as a decimal. It's kind of your call. Now, I will warn you, the answers you get if you keep it a fraction versus if you round it are going to be slightly different. So don't freak out if you look at the key and there's that slight difference. So here, and I'll even show you that in a second when we're done. Now, the only thing keeping me from getting to x is the 20. Now I can use the log of that base. But not until then. And once again, when I'm typing it in, I'm going to do the log big, log of my of value, divided by log little. Now, what if I wouldn't have changed this to a decimal? What if I'd have done negative 26 divided by negative 6 and did math enter? Okay, I had 13 over 3. So when I typed that in, that would have been my log big. My log 20 still would have been my log little. Okay? In this case, I'd have just rounded this up. It would have been 0.4895. Am I going to mark that wrong on a quiz if you do that? No. Okay, I still know that you're doing the right thing. So either one's going to get me there. So if it's a little bit off to one side or the other, that's okay. And then the last one I want to do up here, just so we don't think, oh, so there might be one step. Oh, there might be more than one step. First, find that term where your variable is. Anything that's not in the box, I'm going to do an opposite. Once I get here, again, what's the next thing that's in my way? The 3 is. Okay? Can't divide it. That's an exponent. So I use my inverse. And once again, once I get to here, log of my big, divided by, whoops, doesn't help if I don't put a number in there, divided by log little. 4.011. And then I'm going to, since I don't have b by itself quite yet, I'm going to add my 2. And again, use the calculator if in doubt. Don't end up with 4.013. Don't do all that work right and then end up with the wrong answer anyway. That's no fun. So if it's just numbers there, but my variables are in exponents, I'm going to use log as my inverse. Okay, but only after I get it by itself can I do that. Now when I hit the next section, it's a little different. Solve each equation. Does your answer work? I noticed something right away. There's lots of logs here. I can only have one log on a side, and I already heard somebody say the word I'm looking for. We're going to be doing some condensing. And we'll go as a reminder from yesterday. Plus is going to turn into multiply. Minus is going to turn into divide. And we're going to see one of each of those, I think. Oh, yes, we are. Okay, I wanted to make sure. I'm going to switch those up, though. Okay, so we're going to start with number 10. So I'm going to look on the left side. Okay, I got 2 logs. Can't have 2 logs. Can only have 1 log on a side. So I start to look at getting this into a single logarithm. X squared minus, turns into divide, x squared divided by 5. X squared divided by 5 equals log 9, 5. Okay. Well, now what? Well, I got logs on both sides. They both have the same base. That's a good thing. So how do I get rid of them? Well, to get rid of a log, we exponentiate with that value. And those are inverses. Those are opposites. And so what do I have left? I have x squared over 5 equals 5. And now we're back to algebra 1. So once I get there, okay, I want to get x squared alone. What am I doing to it? I'm dividing it by 5. What's the opposite? Multiply by 5. Whatever I do to one side, I have to do to both. X squared equals 25. Take my square root and reminder. Quadratics, things that are squared, are going to have 2 answers. So it's not just 5, it's plus and minus 5. And you're like, wait a minute, why are you saying does your answer work? Do I have to plug every single thing in? No. Okay? What you've got to make sure is that you're not taking the log of 0 or a negative. So if I plug this in, if I square a number, that's going to be positive. And so since I noticed that's true for 5 and negative 5, my answers are going to be okay. But I've just got to make sure that I don't end up with that negative value or 0. And we're going to see that here in one of these in just a minute. Actually, we're going to see it right now. What am I talking about? So I'm going to roll down here to number 15. I see again, need to condense. I got 2 logs here. Ooh, I noticed something else. I don't see a little base number. What's my little base number when I don't see one? 10. Ooh, I got more of you saying that now. That's good. Okay, that's going to be important once we get condensed here. So I look and I go, okay, what do we got working here? We got log base 10 x times x plus 15. You're like, ooh, a lot of parentheses. A lot of parentheses because I'm not going to type that into the calculator yet. But what I am going to do is I'm going to simplify this part. I'm going to go ahead and I'm going to distribute that x through. And we're going to take up all of our space over here too, I have a feeling. So x times x is x squared plus 15x. Okay. Now we're more to a part that we're used to. It's time to exponentiate. It's because I got to get this log out of the way. So I'll get my 10, get that out of there. We're going to work up to the side here a little bit, so let me scooch over. So I've got x squared plus 15x equals 10 squared, which is 100. Okay? Anytime we get into a situation like this, everybody wants to hang out with x squared. So the only person not hanging out with x squared is 100. So we're going to minus that back over. And then yes, it's our infinitely greatest favorite of all time. We need to factor. And again, I know this isn't easy sometimes, especially when the numbers get bigger, which is why we bust out the calculator and we go, okay, what do I know? Well, I know that my multiply number is negative. So I know it's one of each sign. I know my add number is positive, so it means the positive number is going to be bigger, but these two numbers are going to be 15 apart from each other. So I'm like, okay, how do I want to do this then? Well, I can just start dividing some smaller numbers in. Well, 2 and 50 are not 15 apart. That's a lot further apart, so that isn't going to work. What about 4? 21 apart. Ooh, we're getting closer. Keep trying. 20. 5 and 20. Ooh, 5 and 20 are 15 apart. Positive number is going to be the bigger one. So I get my 20, I get my 5, multiplies to negative 100, adds 15. And then I set those equal to 0. So if I do that with x plus 20, I end up with negative 20. If I do that with x plus 5, I end up with 5. Before you circle it, you've got to make sure, does it cause a negative log? Okay, if I plug in 5, that's just 5, that's fine. 5 plus 15 is 20, that's positive. Okay, that's good. Negative 20. Oh. And again, in case you didn't see this yesterday, let me pull this back up for a minute with negative 20. If I plug in negative 20 there, I'd be doing the log of big divided by log of little. You can't do it. It's not real. I can't take the log of a negative value. So that is not an answer. I have to check that. I have to do my due diligence. If I don't, that's a place where I can start losing points on a quiz, or in this case, coming up a test. Okay? So now, as we head to the back, we're going to take a step back. For some of you, maybe this is the side you're going to want to do first. Condense each expression into a single logarithm. Okay, I got to go back to my steps, and they're still over on the sideboard for me to help me out if I need them. When we're condensing, we do power first. We do product second. I'm looking to make sure I didn't flip these around. Nope, I didn't. Okay, we do quotient here. Okay, power in this case means coefficient to exponent. I'm not going to do anything else yet. I'm going to recopy the other stuff. But on this last one, that 2 is going to swing around and become z squared. So coefficient, maybe we can do this. Coefficient to exponent. Maybe you need to write it out more than that, but that's all I have room for. Product. Add to multiply. I see 2 of those. So now it looks like I can get down to 1 logarithm. Log 7. And I start writing my variables. X, when I see a plus, that becomes a times dot. Log 7y. Plus becomes a dot. Log 7z squared. And then if there would have been a quotient, which in this case would have been taking minus to divide, that's what I would come up with next. So, I look and I go, okay, I don't have any of those this time. That's as far as I'm going. And I'm kind of peeking at it that way. Okay? The other one here we're going to play with, because I went out of order of my own doing, is number 20. Same idea. Power is my coefficients. If I have numbers that are in front, those become exponents. And notice on my second one with the 5, I'm not taking the minus with it. We're leaving the signs alone, because we need them for another purpose. Oops, that's V. Do I have a product? Do I have a plus? No. Don't have to do that this time. Do I have a quotient? Do I have a minus? I do. So when I go to my single log, we've got u to the 20th minus, becomes divide, makes a fraction, v to the 5th. I'm done. Piece by piece by piece. Okay. When we get to expand, we go the other direction. So when I get down here, okay, and I won't have that at the top. You'll hopefully you've got it on your paper, or you can kind of remember as we go. When we get to the expand, here's the part we'll kind of talk about. On this one, if I have a quotient, I would do that first. Except for one exception here. My one exception is if I have stuff going on the outside, but we're not there yet. So otherwise, normally here, I would go quotient, but on the first one we're doing here, 25, we don't have that first. Then, as we kind of peek over there, if we have stuff with, and I switch those around over on the other board when I rewrote them, that's no good, would be product, and number 3 is going to be power. We'll have to get that set on the other board. Don't want to give you the wrong directions. So when I'm doing 25, I don't see any minus division. Nope. Product, though, I do see times. So what we're going to do is we're going to do the exact opposite that we did up here. So now I have times, that turns into plus. Okay, because we're undoing this other piece. So here I've got log 3, 7. Okay, that times is going to become plus. Then I have a new log base 3 of 11. And I see another times, that's a plus. Log base 3 of 8 cubed. So that takes care of my product part. My power part now goes from exponent, and I have one, back to coefficient, back to what's in front. So that 3 goes away from being the exponent on my 8 and goes to the front. Once I hit that last part, that exponent part with power, I'm done. That way I don't have to think about it a bunch and go, am I done? Am I really done? I'm not sure if I'm really done. Let's see. Don't have to do that. So finally then, these last 2. And then seriously, you've got examples for everything that you could run into with these logarithms. And then hopefully we can put some of our focus back into growth and decay starting tomorrow. Okay, I get down here. I'm just going to put parentheses around this. So first thing, okay, quotient. Do I see division? I do. So what's that going to look like? Okay, it's going to look weird for a minute. Just stay with me. Since I haven't done anything in those first 2 terms, I'm going to keep them together for a minute. The division becomes minus. So I got that taken care of first. If I peek back up, okay, once I get that, what's next? Product is. I see one right there. That's going to become a plus. So I would have log base 3 is 7. My times becomes plus. Log base 3, 11 to the 5th. And that last part's going to stay just the way it is right now. So my last step is power. Do I have exponents that are coming back to the front? I sure do. So my first term would stay the same. My second term now has a coefficient, and so does my third term. And I'm set. And the only thing that ever can come into play with these that takes me out of my normal order is if at the start of my problem I have an exponent on the outside of my parentheses. Whenever this happens, and I'm going to put 1s on these to remind me, I'm going to use my exponent rules to clean this up before I start. Okay, but this is the only time I make an exception. That is not a power that I'm swinging back to the front. That won't work. So here I've got log base 3. 3 times 6 is 18. 1 times 6 is 6. 1 times 6 is 6. And now it actually starts to look a lot more like number 25 did. But I got to get that first step done. Now I go through my steps. Do I have any divides? Nope. Do I have any times? Oh, I sure do. So the times are going to become pluses. And then I write another log. And I see a times, which becomes plus. I do another log. Whoops, and I'm off the screen. Bring it back in. And then my last step when I'm expanding is my powers. So the 8 goes in front. The 6 goes in front. And the 6 goes in front. 18. Thank you. Does help if I actually write the things down correctly when I'm recopying them. Again, what you're looking at on this sheet is about almost half the exam, okay? When you see that on the review tomorrow, you're going to be like, oh, if I know this stuff, this is going to go pretty well. And it's a chance to get a really nice, big, pointed score into your summatives if you've been struggling on some stuff. So do take the time to try some of the others. Check them up here in the binder. Okay, if you desperately want the review ahead of time before tomorrow, I have a few copies in here. Or if you take one today, please don't take one tomorrow, because then I will run out. Okay. But give these a go, give these a shot. If they're not answering with the matching up with that, ask me. Let's get these set.